Hello viewers, today I'd like to continue my journey with equations reducible to the quadratic equation form. This is a simple example of a miscellaneous equation which can be reduced to the quadratic form. This is what we're planning to solve. Solve to find the real values of x if 5 power 1 plus log x to the base 4 plus 5 power log x to the base 0.25 minus 1 is equal to 26 by 5. This, if you look at it, doesn't look like quadratic, right? But this can be reduced to a quadratic equation through proper substitution. Let's see how. So to start with, we observe that this is log x to the base 4 and this is log x to the base 0.25, and that 4 into 0.25 is 1. That is, 0.25 is nothing but the reciprocal of 4. So that should ring a bell in our minds, right? We're going to use this property of logarithms, that log a to the base b times log b to the base a is equal to 1. This is an important property that we need to know. And of course, log a base a is equal to 1, wherever these two are defined. So if we want to look at log x to the base 0.25, right, we could write this as log x to the base 4 power minus 1, because this is nothing but 1 by 4. 0.25 is the inverse of 4, right? And there is one more property that we would like to use. Log a base b can be written as log a to the base c 2 divided by log b to the base c. So we could write this using this formula. Let's say, because we already have base 4 here, let's convert this also to base 4. So we could write this as log x to the base 4. Here a is x, c is 4, b is 0.25, which is 4 power minus 1. We could write this as 4 power minus logarithm of 4 power minus 1 to the base 4, right? We could write it this way. Log x to the base 4 power minus 1 is equal to log x to the base 4 divided by log of 4 power logarithm of 4 power minus 1 to the base 4, using this concept here. So of course, we also know that logarithm of x power n is equal to n times logarithm of x. So we could write this as logarithm of x to the base 4 divided by minus 1 times logarithm of 4 to the base 4, because this is logarithm of x power n, right? So this we could write as n, which is minus 1 times log 4 to the base 4. Of course, log 4 base 4 is 1. So we could say that this is log x to the base 4 divided by minus 1 into 1. So this is simply minus log x to the base 4. Or in other words, log x to the base 0.25 is nothing but negative logarithm of x to the base 4. So let's work this out here. So we could rewrite the given equation as 5 power 1 plus log x to the base 4 plus 5. Now this we have proved to be minus log x to the base 4, right? Minus log x to the base 4 minus 1 is equal to 26 by 5. Now this should, if we take this minus common out here, this should ring a bell, right? So if we take 5 power 1 plus log x to the base 4 as t, let's say 5 power 1 plus log x to the base 4 is t. Let's do the substitution. Then what happens is, this is t plus this is 1 by t, right? So we can rewrite this. We can rewrite this equation as t plus 1 by t is equal to 26 by 5. Just through this nice substitution, right? So this is a quadratic. Of course, this can be simplified to a quadratic. Let's cross multiply. We would end up with t squared, right, or 5t squared minus 26t plus 5 is equal to 0. We take the LCM and then we cross multiply, then this will become t squared plus 1 divided by t is equal to 26 by 5, and then we cross multiply, 5t squared plus 5 is equal to 26t, or we bring that 26t to this side, we have 5t squared minus 26t plus 5 is equal to 0, right? So we could solve this, right? This would be t is equal to, using the standard formula, right? So, or we could factorize this as well, not a big deal. Actually, we are looking for two numbers whose sum, right, is 26 by 5 and whose product is 1. So we could not a difficult task. We could rewrite it this way, or in other words, 5t into t minus 5 minus 1 into minus 5, or 5t minus 1 into t minus 5 is equal to 0, right? Or t is equal to 5 or 1 by 5. If you do not know how to factorize, you could use the quadratic equation formula as well. But this is factorizable, so it's much easier to handle. This is 5 power plus or minus 1. These are the two possible values of t. Now, what is t? Let's look at our substitution here. That means 5 power 1 plus log x to the base 4 is equal to 5 power plus or minus 1, right? So the bases are the same on either side, so we could equate the powers. So 1 plus log x to the base 4 is equal to plus or minus 1, right? Or log x to the base 4 should be, if it's plus 1, then log x to the base 4 would be 0, and if it's minus 1 here, then log x to the base 4 would be minus 2. Or in other words, x would be either 4 power 0 or 4 power minus 2, or x is equal to 4 power 0 is 1, 4 power minus 2 is 1, but divided by 4 squared, which is 1 by 16. So these are the two roots, possible values of x, which satisfy this equation. Hope you like this neat problem and this nice substitution. Please subscribe to our channel to take a preview at our previous videos, as well as to take a peek at our upcoming nice video presentations as well. Thanks for watching.